Welcome back, everyone. In this session, we are examining the secant function, y equals secant of x, and deriving its differential coefficient from first principles. Let's work through the proof step by step. We begin with our standard function setup. Let y equal secant of x, which we'll label as equation 1. Next, let's introduce small changes. As x updates by a small increment, delta x, y will experience a corresponding change, delta y. This gives us equation 2. Y plus delta y equals secant of x plus delta x. To isolate our change in y, we subtract equation 1 from equation 2, which yields delta y equals secant of x plus delta x minus secant of x. To simplify this expression, we rewrite the secant terms in terms of cosine. Finding a common denominator and cross-multiplying gives us a single unified fraction. Now let's look at the numerator. We can apply the cosine subtraction identity. Cosine of c minus cosine of d, setting c as x and d as x plus delta x. The identity simplifies our numerator neatly into 2 times sine of 2x plus delta x over 2, times sine of delta x over 2. To determine our derivative, let's divide both sides by our change in x, delta x. To set up our standard limit, we rewrite the division to form a standard sign over argument component, matching our delta x over 2. Now we apply the limit as delta x approaches 0 to both sides. The left side resolves to our standard derivative notation, d over dx of y. Evaluating the limits, our special limit fraction goes directly to 1. On the remaining part, as delta x drops to 0, the numerator becomes sine of x, and the denominator becomes cosine of x times cosine of x. We can split this fraction into 1 over cosine of x multiplied by sine of x over cosine of x. Since 1 over cosine of x is secant of x, and sine of x over cosine of x is tangent of x, we reach our final conclusion. The derivative of secant of x with respect to x is exactly secant of x times tangent of x. Thank you so much for watching today's lesson. If this first principles proof helped you understand trigonometric differentiation better, don't forget to hit that like button, subscribe, and share. See you in the next video.